Midas is actually a company who has the #1 market share in civil engineering software solutions. We have almost 10,000 clients and 30,000 licenses distributed of all the softwares. So first of all, let me present all the different softwares of Midas. The first one is for the building industry. So it is called Midas Gen, and it is composed of several softwares for the building and modular and D-Shop. I will explain later what it is. Second one for the bridges. So these are all industries of Midas. So Midas has a software called Midas Civil, which is very strong to simulate bridges and all kind of bridges. Midas has also Midas GTS for the geotechnical and the tunnel engineering. So 2D and 3D geotechnical analysis and mechanical analysis, Midas NFX. So during this presentation, this webinar, I will go quickly on each software and show you a small demonstration of each software. So I know there's some engineers who are interested by buildings, some engineers interested by bridges, other by geotechnical, and maybe by mechanical also. So I hope you will enjoy all parts of this presentation. First software is Midas Civil. So what Midas Civil can do, so this is a very large view of the software. Midas Civil can do all kind of bridges and has a lot of project application all over the world. So this is a short introduction of what I will show you right after. Midas Gen is also famous for all kind of building analysis. So as you can see, pushover analysis, construction stage analysis, post-tensioning or time history, all that can be done using Midas Gen. Midas FEA is, I didn't talk about it in the previous slide, so Midas FEA is for detailed analysis. Midas GTS for geotechnical analysis, so any kind of ground or geotechnical structure, tunnels, subways, all that. And finally Midas NFX, which is specialized for the mechanical industry and has also very good features. So first of all, I think you know all these very famous structures. One is the Burj Khalifa, the Beijing Olympic Stadium, or these bridges, the Sutton Bridge, which is the world's longest cable-stayed bridge, and the Incheon Bridge in Korea, the 5th longest cable-stayed bridge. Well, all these buildings and structures have a common point. They all have been simulated using Midas softwares. So here you have an overview of these buildings inside Midas. And we have some key clients all over the world. So here is a small list. It's just a small portion of the clients we have. So right now, I will begin the first demonstration about Midas Civil. So Midas Civil is a generalist software for bridge analysis. So it is actually providing advanced technology on stage segmental bridge, construction stage analysis, cable stayed bridge, dynamic nonlinear analysis. You can almost do any kind of analysis about bridges, and all bridge which are very complex shape have been modeled using Midas Civil. So these are a few examples of the type of bridges you can model. The conventional bridges, so it can be the frame bridge, the beam bridge, the slab bridge, the staged segmental bridges, like the incremental launching method can be done, balanced cantilever, precast segmental bridge, all that can be simulated using the construction stage analysis, and cable stayed bridges. So Midas Civil has been sold in more than 70 countries over the world. So actually 8,000 licenses, and these are a few of for big clients. And this is a map of the world. So there's a lot of bridges in Asia, in Europe, and in America, and we have example of all these bridges using which have been simulated using Midas. So for example, this is the Ironton-Russell Bridge in US, or the Weirton-Stoneville Bridge, also in US. This is in Mexico, again in Mexico. This is a conventional steel bridge. This is again in Mexico. We even have a project of bridge from Bucharest in Romania. So I will show you this bridge right away. So this is a railway bridge in Netherlands. In Russia, St. Petersburg, this is cable stay bridge. And this is the Basarab Viaduct bridge. So it's located in Bucharest, in Romania. And these also have been simulated with Midas Civil due to the nonlinear dynamic time history analysis and the rubber isolators. So it's a very complex type of analysis. So this is again in St. Petersburg and in Vietnam. Again, Vietnam. Right now I will show you a demonstration of Midas Civil. So I will show you how to model a simple bridge and how to make a moving load analysis on it. So let me go into the software. So here it is. So the interface is quite simple because you have several types of menu with big icons and different tabs to use all the features. So I will show you right away how you can model a simple bridge in this. So the first thing I will do is open a new project, and I have to assign some material properties. So I open this, add the material. So you have a library of material. So I will directly select some steel material and add it. And you have also a section library. So the section, you can use any conventional section, I section, T section, box, anything. You have also SRC section, combined section, pre-stressed concrete section, typed section, and composite section. Actually, I will not define right now. I will just use the data from previous analysis. So I will import the data from previous analysis I've done. So 2 materials and 6 sections. So the section I will use to model the bridge. Now if you go in this tab, you see the sections and the materials. So they have not been assigned yet, so this is why they are in blue. So right now I will show you how to model a simple bridge. So first of all, I will use structural wizard to model an arc. So I choose the material, arc rib, and you see in just a few clicks you have your arc. Now I will project the nodes here on, so this is the hangers. I will create the hangers by projecting this on this line. So as you see, I created some hangers. The thing is that the orientation is not good, so I will just select them, change the parameter, the element local axis, and turn them to put the right orientation. Now I will create the main girder of this bridge by selecting that. So you see in a few clicks you can create the arc, the hangers, and the rib. Now I will just translate all that. So select all these elements, select the width of the bridge, so 14 meters, apply, and now I have the second arc rib. Now I will create the cross beams. So to create the cross beams, I have to extrude these nodes. So using this tool, I can simply select all these nodes. I select the cross beam section. Again, I will use the project option. And I created the cross beam. Now I will create the stringers. So by selecting the cross beam, I will activate only this, so you can see a bit better what is happening, and unactivate the section. And create the bracing and the stringers. So first of all, like that, the main bracing, and create the little parts like that. So actually you can also directly select this, and I will use the translate option, because if you have a very long bridge, it's better to do like that than just to click on the screen. So you see in 2 clicks I create all the stringers. I will mirror this, and now I will create the strut. So I activated this part, and again using create element, strut, I will just click on the screen like that. To create the struts. Now, by activating only the struts, I will create the bracings on here in the stringer, create element, and you see the auto selection of the middle of the element is quite good, because you just have to put your mouse on the element and it will automatically click on the right point. So now I activate everything, and I have my steel bridge. So I can activate the section so you see a bit better. So you see, just in 2 or 3 minutes you can create any kind of bridge. Of course you have to know how the software works, but when you know it, it's really quick. Now let me show you how to put the boundary condition on that. So go on boundary condition, define a support, block. I will block all that. So first of all, I define the degree of freedom on translation. Okay. After that, I will put the beam end release. So to put the beam end release, I will select the angles. So to select the angles, you can use the filter. That. Apply. So here there's a small sign in green to show you that you assigned the beam end release. Now I will use this select identity tool to select only a special section, the bracing and the stringers. Okay, and I will pin them. Okay, and now for the last part, I will select the cross beams. Okay, and so using this selection tool, I can use pinned fix for one side and the fixed pinned for another side. Okay, so now all the boundary are assigned. It's time to create some load cases. So the load cases I will create are first of all the dead load. So in the type of load, you see you can assign all these types of load. So here I just choose dead load. And the sidewalk load, which will be also dead load. Apply. Oops. Okay. Now for I will apply the dead load only on the main girder to simplify a bit. So use the elements beam load, and I will select only the girder. Okay. And apply a load of -90. Same for the sidewall load. You just need to save. So you have automatic save. So you cannot lose your job, so it's a good thing. Okay, apply. And now I will show you how to create a moving load. So for the moving load, first of all I have to define a structure group. So you have a window which is called group here. First of all I have to select the cross beams. So I'll select the cross beam. I will create a structure group called cross beam. And simply by drag and drop it on the window, you can assign these elements to this structure group. So I will use this structure group to assign the moving load. So for the moving load, go in load, moving load, and you have several codes you can use. So in this case, I will use the arrow code. So if you use arrow code, all the norms which are in the code are already in the software, so you don't need to check everything. So the first thing I will do is create some lanes for the circulation. So the lane 1. Here I use the crossbeam group I just created, and I select here. Okay, so I created one lane. Now another one. Okay, crossbeam. Okay, I created two lanes. Now I have to add some vehicles. So from the standards, here as I'm using arrow code, you have several types of standards. I will use one, the road bridge, so you can modify the coefficient if you want. and I will use also the footwear and footbridge load. So I added two types of vehicle. Now I have to create the moving load case. So moving load case. I select the vehicle. Okay. I include the lanes. Okay. Now I can go into the moving load, and I can launch the analysis. So now I added all the condition and I just launched the analysis, and you see in 1.4 seconds it is solved. So you can already check the results. It's quite quick. Now I will do a load combination after the result, because it is linear static analysis. So I will combine the results. I will create a load combination of the dead load, the sidewalk load, and the moving load. You can add some factors if you want. And now I will show you some results. So first of all, the reaction at the 4 points of the bridge. So it automatically calculates the reaction. Second thing, the deformation. So the deformation shape, that. So the option to add, you can check here if you want the legend, for example, you can check this option and the legend will appear here. Displacement control, so you can view displacements, that. See the values. You can also view an animation of this. You can see the beam diagram, that. The stresses into the beam, etc. And for the moving load, you have the influence line. So for the reaction, for example. So in order to see a bit better, okay, I had the section. Okay, so this is the reaction influence line, or displacement. You can increase the scale. So this is a good thing also is you can convert this result into a static load to apply it on your bridge afterwards. And you have also moving tracer. So you can check the moving tracer at the same time for the moving load. Okay, it's all for this demonstration of Midas Civil. So it's not finished. I hope you're still listening. So now we'll go to the next part of the presentation, which is Midas Gen. So now the building engineers can come back. Okay, so I'll just wait 1 minute and I will begin about Midas Gen. So we have a chat section in this system for the webinar, so if you have a question at any moment, you can ask it. Okay, let's continue. So Midas Gen is a professional software for building applications. So Burj Khalifa, Kingdom Tower, or Beijing Olympic in China were simulated using Midas Gen. It is not only Midas Gen. You have a full solution, which is a one-stop solution: Midas Modeler, Midas Gen, Midas D#, and the CAD interface, and all that together creates a full solution. So you can use Midas D# to auto-draft your building, for example, Midas Modeler to automatic generation of the model, and Midas Gen, of course, is for the structural analysis. Now, you have data exchange between several softwares like TechnoStructure or Revit. You can also import your data from STAAD, MSc Nation, and SAP 2000. And of course, it's possible to export or import AutoCAD DXF format. So Midas Gen is practical and is used in all kinds of structures: stadiums, power plants, hangar, airports, transmission towers, cranes, pressure vessels, machine structures, underground. All that can be simulated. And also it provides very nonlinear types of analysis, like pushover analysis, for example, base isolators and dampers, fiber analysis, and various types of mass seismic design. So now let me show you a small demonstration of the software. So I think you're still here. Okay, let's close Midas Civil and open Midas Gen. Just wait 1 minute. Midas Gen. This is Gen 2013. So as you see, the first page when you launch the software is actually a Midas website. So on Midas website you have a lot of training, support, and you can also download directly the trial of the software. So you just have to log in on the website and you can directly download the 30 days full trial of any Midas software. This is good to know. So the address is midasuser.com. Okay, so let's go for the demonstration. I will go from this file. So I will show you how to do a slab design in Midas Gen. So you see there's already some columns, some beams. And now, first thing I will do is to generate the slab. So to generate the slab, you have an option which is very useful for automating the slab. So I will select the material, the thickness, okay. So you just have to select this zone, and the software will automatically mesh your slab. That. Now you have some walls also in your building, so these walls can also be meshed, of course. So using planar elements. So in this case, first of all, select the walls and define the thickness of the walls, the material of these walls. Click on apply, and see the walls are generated. Now you can activate the section to see a bit. So now it's only one floor building. If you go in the walk, you see some support condition is already assigned. So all the columns have been fixed, and the self-weights is already assigned to the building. So what I will do first is to assign pressure to this first flow. So I will assign it to the live load case. So you select your flow. You can change the unit. -2, so it will be kilonewton by meter square. Apply, and you see in just a few clicks all the pressure is assigned to the first flow. Now Midas Gen has very useful features if you want to create a full building with using the building generation tool, for example. So select the number of times you want to copy this flow. You have to put distance between each flow and apply. So in a few clicks you see you have your building which is defined. So I will hide the nodes so you see a bit better. Okay. So now I'll show you how to assign the wind load to this building. So sorry, before the story generation. So there's also a very useful feature in that you can auto-generate the story data. So just in 2 clicks like that, all the data from the stories are defined. You can consider or not the flow diagram, depending on what you want to do. Now I will show you how to assign the wind load. So all the types of load you can assign are here in this menu. So the wind load can be defined using Eurocode, for example. So Eurocode 2005. So it will be in X direction for the first one. So you can define a wind profile with the different stories. Okay. Yeah, I will assign for the Y direction. Okay, now I assign the wind load. And now another thing, I will assign the response spectrum data. So MidaGem is very useful because you already have the design spectrum data inside. So you just have to select the code you want to use, the Eurocode 8, for example. Click on OK, and you see the spectrum is already provided. So just add it to your analysis, create your spectrum log case, X direction. You can apply some damping. I have to define some eigenvalue too. So you have several methods to define the eigenvalue: the length, subspace, or width vector. And in our Y direction too. Okay. Okay, now I just can launch the analysis. Okay. Now I will show you the reaction first. So you can visualize the reaction at each column in the building, and the maximum reaction is shown in red here. The second type of results are the displacement. So you can do deform shape first. That. the displacement control, you can see the beam diagrams. In all the model, and also the stresses into the plates in the slab. So now I will show briefly how to design your building. So Midas Gen is very good for the structural designers of building because it has a lot of codes for any type of design, steel design, concrete design, or SRC design. So design code here can be chosen, so you can choose error code using the recommended annex. Then you can define the partial safety factors. So again, depending on your analysis. And you can modify the rebar data, so you can define directly in the gen the bar in each column, for example. So this is the column in all the model, and this is the bar in each column. So just by changing the numbers here, you can increase or not the number of bars inside the column. And after that, you can add and replace and check the design. So it will automatically check the column design, for example, and tells you if it is okay or not. So if it is not, it will give you advice how you can increase the number of bars inside your columns. You can select one column only. It's not only for all the columns in the building. You can select a small part of your building only. And it's not only for column, it's also for beams, also for slab, and for walls. So here you have the information, the result. So it tells you that the design condition to use is this one, and this is the applied loads, the action forces, the interaction diagram, and the shear force capacity. You have also the PM curve, and you can click on this button to update the rebar in your model. Now I'll show you the slab design. So for the slab design, it's almost similar. So what I can do is select only one floor, for example. Okay, and show you the rebar data, for example. So it will read the design concrete slab data, and he will tell you in which place you need to make rebar into your slab. So I guess the parts in red need some rebar. You can check also the resistance ratio, the wood armor moment. Okay. And you have also some tools for checking the shear, the slab shear checking. So at each intersection, it gives you the value of the shear between the different parcels of the model. You can also see the stress on this. So you see the stress is represented by red red segments here with this value. So just by looking at this, you know where the shear is important and where there's a lot of stress. Okay, it's all for the demonstration of Midas Gen. So I will come back to this presentation. So Midas Gen has also dynamic report generation. So after doing your model, your analysis, you don't need to check everything to make yourself your reports. Just by one click and drag and drop, you can generate automatically the report. And the report will generate itself with when you modify the model, so you don't have to do it every time. So it's very powerful. And these are a few examples of Midas projects. So the Burj Khalifa in the UAE has used Midas Gen. One of the reasons was the construction stage analysis and also the shortening of the columns, because it's very important in a very tall building like that. The Moscow City Palace Tower in Russia, and all the famous buildings, the Beijing National Stadium. Okay. Now come the third part about geotechnical engineering. So Midas GTS is the tool for geotechnical engineers, and the demonstration will be a bit shorter because we have to be quick. But I will show you also the interface and the types of analysis you can do. So first of all, Midas GTS can do all these types of analysis: static, construction stage, C-page analysis, semi-coupled analysis, consolidation, slope stability, eigenvalue, equivalent linear analysis, response spectrum, and time history. So all that in one software. Midas GTS can model very complex 3D structures. So mainly it is used to model underground structures like the subway stations and the plant or the nuclear installation this time, and to model the pile of very high buildings. So the pile diameter and the pile group behavior can be modeled and analyzed. Also, 3D soil structure interaction can be simulated. Midas GTS can simulate unconventional tunnel intersections. So it's done for very complex underground stations, and it has been widely used over the world for the creation of new subway stations, for example. Also the shield TBM method, like that. So this is the shield TBM, can also be modeled. Midas GTS can consider the stage analysis, the construction stage analysis, so you can excavate with different stage and see the displacement in your model. So I will show you right that in the software. I will close Midas Gen and open Midas GTS. Okay, so here I will simply load the model. It will be a bit quicker than the previous demo, but it's in order to show you what you can do. So this is a 3D tunnel connection gallery model. So it is a 3D model. Midas GTS can simulate 2D and 3D, the two together. Okay, so this is the model. So this is underground. For you to see better, I will hide the ground material, and this is the tunnel structure. So this is the structure which has to be excavated, and here you can see the piles in the ground. So if I show you the result of the analysis, this is construction stage analysis. I will show you first the displacement. So the first stage is the isostatic state, and you see when you do the excavation like that, you can see the displacement in your ground which is created by the excavation. So this is a powerful feature of Midas GTS for tunnel and underground structure excavation. So this is the final state of the displacement in the ground. I can show you again. So you can change the angle also. To see like that what is happening when you excavate your tunnel. So it is particularly useful when the condition of the ground is very complex. When you have several layers of different materials and you don't know what is happening, Midas GTS can calculate everything. And there's a module to import directly the data from the map. So you don't have to model the ground exactly like it is, but you just import the data from the file, and it will directly model the ground like on your map. So I can show you the stresses also. So the Midas stress, for example. Okay, it was a very short demonstration about Midas GTS, but we will organize other webinars about it. So if you're interested, just tell me, and we will invite you for a specialized webinar with more details about each software. Because here it's a very large introduction, so I cannot talk about everything. Okay, so Midas GTS can also be used for dynamic analysis. So for example, the train, which is going on the ground, it supports 64 bytes system. And these are a few projects. The Onkalo nuclear waste disposal in Finland. The Trans-Hudson Express station in the USA. So it's a very complex structure if you look at the screen. King's Cross station in the UK. the Dubai Tower in Qatar, which is a piled graph foundation of 88-story building. Palazzo Versace, the Odeon Tower in Monaco. You can do also dam analysis. Okay, now the last part. So I will be very short about this part because I think there's only one engineer here about mechanic. So Midas NFX is a very powerful software also for mechanic analysis. So NFX has two modes, designer mode and analyst mode. So analyst mode, designer mode is for the person who are using CAD model and wants to do quick analysis on it. The analyst mode is for the specialists who really know everything about FEM and analysis. And NFX can simulate all these analyses: linear static, model and buckling, nonlinear and quasi-static analysis, dynamic, 32 and 64-byte algorithm, and there's also heat transfer, fatigue analysis and composite, and CFD analysis. So again, let me show you quickly a demonstration. I will try to be quick. So I will first of all go into the designer mode, so you can switch from one mode to another like that. Create a new project, import a CAD model. So So in NFX you can import all these type of CAD model: Parasolid, Arcis, Step, IGS, ProE, CATIA, SolidWorks, Unigraphics, Inventor, all that can be used. So this is an assembly model. NFX can, first of all, I will assign the materials. So NFX has also a library of more than 1,000 materials here. So I will just use, let's say, aluminum alloy. So all the coefficients, structural, thermal, factor safety calculation, all that are available. You have linear and nonlinear material. You can even simulate rubbers. So you can assign this material to your different parts simply by drag and dropping it on the model. Now you have a feature to simplify the model, because there's a lot of small holes and fillets, and this is a bit, when you want to mesh it and obtain good results, you need to suppress all that. So using the auto simplification in Midas NFX, you can directly find the holes and the fillet and remove them. So in just a few clicks like that, you have a model which is, let's say, cleaner for the analysis. You can assign some contacts between the different parts. So just by selecting all the parts, the type of contact you want to use, like you see, in less than 1 second, 26 contacts have been assigned. So if you click here, you can view on the screen directly where is this contact. So here it's between the blue and the red part. Now you can assign some boundary condition directly by selecting on the model. So you can fix these parts, for example. You can assign static load. the meshing is very convenient also. So designer mode only provides 3D mesh, but the analyst mode you have any type of mesh inside. So I unselect these two parts, and NFX used the multi-core to mesh all the parts of your model. So it is very quick to model any big model, let's say, because in mechanic you need to have very powerful meshing tool. So, and I will use hybrid mesh to mesh these two parts. So hybrid mesh actually is a combination of hexa mesh and tetra mesh for better accuracy, and also it improves the speed of the calculation. Okay, so if you zoom on this area, you see the mesh is really good here. Now that I've done all that, just have to create an analysis case. So these are all the analysis you can do in NFX. So linear static, buckling model, nonlinear steady heat transfer. You can do nonlinear static as well as nonlinear dynamic analysis, and very complex type like explicit analysis, implicit, all that is provided. So I just create my analysis case and run the analysis. So you see for this 20,000 elements model, it only took 10 seconds to get the results. So it's really quick. So now I have the deformation of the model. So you can see deform shape and deform shape. You can animate all that. And the good thing is that you can zoom, you can rotate during the animation. You can view the stress also inside the model. So inside this part, for example, you have some tools like the ISO surface to see only the stress which is superior to a certain value. Clipping tool to cut your model and see what is happening inside. You can also use the probe tool to get results of displacement, for example, at any point of your model. You can also get the minimum and maximum value at any point. And a lot of other tools. So this was a very quick demonstration about NFX. Now I will come back to the presentation. And we still have a few slides and afterwards. Okay. So NFX can be used for example, heavy equipment, stress analysis of heavy equipment in the industry. Can be used also for aerospace and automotive industry. And actually, Samsung and LG are using NFX in Korea. So this is an example of analysis of durability of the door of the car. And NFX can perform also fluid dynamic analysis. Okay, so now a few slides about the events all over the world. So I hope it will interest you. We Midas organize a lot of events in every countries. So these are a few photos of the events we made in the Czech Republic last year. We open very frequently such events. So there's a conference talk about analysis, about real analysis and engineering cases. There's some workshop also, so you can try the software. You can talk with a lot of engineers together, so it's very good time. And we will organize such kind of events in Romania also. So it's the date is not fixed yet, but I hope we will do that around October. So if you're interested, we will send you the invitation also for this event about Midas. Now you can ask a few questions if you have. Do you have some questions? Maybe I cannot answer all the questions right now because there's a lot of engineers. But if you have some questions, please write them, and we will answer you by mail after this webinar. So please write any question in your chat section. Okay, I will go to the last slide. So actually, Midas is caring a lot about his users, and we would like to know what you think about today's webinar, and what do you want to see next time. So what is your impression about Midas software? So if you can just write it in the chat section, a very short answer for each question, it will be really good for us. And I thank you in advance for your participation. So we would like to know what you think about this webinar, what is your impression of Midas software, and what feature and analysis interest you the most in this webinar. And also we will organize all the specialized webinar on different topic, very specialized topic. So if you are interested to join, please let us know, and I will just invite you for the next topic. You can also tell me which kind of topic you are interested in, and we will just make it for you. Okay, so I will let you 5 minutes to just write something here. Okay, I see we have a lot of participation. Thank you very much again. So if you have any question afterwards about the software, about any type of analysis, about anything, my mail is cyprian@midasit.com. So you can either contact me directly, or you can also contact my partners in Romania, so Dragos and Ionut. Okay, I think it's all for this webinar. So thank you very much for attending again, and we hope to have more contact with you afterwards. If you're interested in some training, or you want to see more videos about the software, you can go on YouTube. Midas has different channel on YouTube. So there's a channel for Midas Civil. So just by searching Midas Civil, you can find all the videos, tutorials about every kind of bridges, for example. If you're interested by Midas NFX, you can simply type Midas NFX here, and you will find a lot of analysis, a lot of content about Midas NFX. We have also some Facebook page. So if you like Midas, you can go on Midas Facebook. So you just search Midas IT on Facebook. And we always share the latest news about the software and about any kind of events we are doing right now. So you see there's a new tutorial, for example. We had a visit of Nigerian engineer last week. So these are the photos up here. We have some videos about the project and the companies, whole new partners. You can just check it on Facebook, and also you can let any comments here if you're interested. Okay. Okay, I guess this is the end. So thank you very much again, and I hope to see you next time.